Cool. My name is Pedro Loigorri. I am the head of the Weather Vigilance Remote Sensor Division, and we work in the office next door. And we watch storms. I will be telling you about it and issue warnings that you've heard about. I'll be sharing with you a bit of the kind of work we do, the nowcasting product we do, which is a very, very short-term forecast. It is defined between 0 to 6 hours since the issuance, but truly it's between 0 to 2 hours or 0 and 1 hour to be like an emergency flash message. I'll tell you about the information we use to issue our nowcasting, and I'll be sharing the objective of this presentation, that is data mining from social networks, social media, and the challenges that face us in the future to keep improving. Our division is set up by 14 meteorologists, so 12 forecasters and 2 heads. There are 2 different roles. One responsibility has to do with issuing the short-term warnings. We call them ACP. And this is a nowcasting product that let us know where the strong storms are. And the other responsibility is vigilance of the volcanic ash advisory center, Buenos Aires. So when we detect ash in a broad region in South America, we issue a report for airlines. So we let them know where the ashes are, where they are heading to, so that they can avoid it. So we work 24/7, 365 days a year, and it's 1 or 2 forecasters working together. However, sometimes it's just one of us. So let me tell you about our work method. We must analyze the available information, just like a doctor looks at an X-ray or an MRI or test results. We obtain a lot of sources of information and we analyze them, therefore creating a diagnosis of the situation. So with that information, we check it against our conceptual values, what kind of storms there are, all the information that we have from previous situations. And nowcasting, because we don't have time to run it in the computer, is mostly regarding watching satellite data or algorithms that say there's hail here, but mostly it has to do with interpreting data. So we have the data, we analyze it through our conceptual models and the previous situation experiences, which can be helpful to know how it could evolve in the future if there are similarities. And then we conduct this forecast that lasts 3 hours in Argentina. As I was saying before, we called it ACP, short-term warning. And this cycle then starts again. The information that we use, radar, satellite, I will show you how often it is updated. It's updated very quickly, so it lets us know of new storms or movement in the storm, so we might have to issue a new warning, a new ACP. So this is a cycle that is constantly in motion. So what is an ACP, a short-term warning? I'll tell you about the objective. We work with a paradigm similar to the one used in the US. They have an outlook, we have the weekly overview or outlook in which we define different phenomena and decide which could be affected. Also the weekly one that is about 2 weeks into the future, determining places of the country that could be affected by rain, fog, wind, and different similar phenomena. Now, closer to the moment, we issue the meteorological alert that is 12 to 24 hours ahead. So we reduce the area because there's greater certainty as to where it will happen. We reduce the area. First, in green, we saw precipitation forecast, but with the alert, we can say that in the next 12 to 24 hours, we expect that in this area there will be strong storms. So the weekly perspective then would be ready, so that everyone can be preparing themselves. The meteorological alert would be steady, and the ACP, the product that we issue using satellite information, would be go. So it would be like ready, steady, go. That's the paradigm that we use. So again, see how the scale is reduced. All this comes to this region, and in real time, we create the ACPs that are these polygon, these short-term warnings. So the area that we watch through ACPs is limited by the availability of the meteorological radar, that is our instrument. We could do it without it, but the quality will go down significantly. The radars that we use to issue ACPs are the ones we can see on the screen. There are more radars in Argentina, about 16. So here you can only see 5. And these are the ones that we consider operational. The others have been recently installed, are being calibrated, so we still haven't incorporated them into our short-term work. So this is the product published in the webpage of the service. We send it by email to decision makers. We share it with the social media and also the media. So we issue the warning, we include the time of issuance indicated here, validity up to 3 hours. So we issue it and we don't terminate it. So we understand that it will be not valid anymore 3 hours later. Why? For instance, strong storms with gusts and occasional hail. And then it explains what provinces or departments will be affected. And then we have a graph for Argentina where the ACPs are issued. You can see the polygon within Argentina so that you can quickly refer to it. And then you can zoom here and you can set the area in which there is risk that there be strong storms with gusts and occasional hail. There's an example here of the radar image that is shown on our webpage. The polygon in orange is an ACP that was issued, and you can see that it was already there before. And when this strong is about to leave the warning area, a new one is issued. And the storms that are not strong don't require a warning. We don't only issue warnings regarding those that might affect the population. So, sources of information that we use. I was telling you the meteorological radar is the tool par excellence. Some do it every 9, every 10 minutes, and the idea is to reduce the update time to 7 minutes. But now it's 10 minutes. Also, we use the US GOES East that provides a feed every 15 minutes. And regarding electrical detection, it has to do with the source. For instance, the US sensor GLM updates every 1 minute. Actually, it's every 20 seconds, but it's too much information for a forecaster to decode. So we can use it perhaps as in a 1 or 5 minute image, and we update it as so, like so. And also we have information centers for conventional surface, that's every hour, and also automated meteorological stations that provide data every 10 minutes. So the average rate is 10 minutes or less. Every 10 minutes there's new information from all over the place, and we need to process it and issue a short-term warning if necessary. So the meteorological radar, the satellite, and electric activity are proxy of what's happening. You're not under the storm and checking it yourself. There are some severe weather patterns And also you can infer what's happening, but it is never 100% certain. So that's when you need to know what's actually happening. And the surface stations can tell you what was the value of the gust or the information on the size of the hailstone. But the rest that has broad spatial coverage, such as the radar, the satellite, and the sensors, are proxy. So here is where we again find the need to know what's going on. So in some cases, what's going on is pretty obvious. If you see this radar image, this is for a case in Argentina, this severe pattern, it's like book, work. It's a supercell. It's one of the most intense storms. So if you make a cut here, you will obtain this image that is really a very common case. You can see perhaps the possibility of large hailstorm here. So if you have this, you can infer that things will be quite significant under this storm. But again, it may not happen. There have been cases in storms that experience all this, and what happened at surface is not what you have expected. Then the radar and the rest of the instruments, I'm just saying radar as an example, are limited. This image encompasses all the limitations that the meteorological radar has. If we want to see rains, we can see them 100k away from the radar. If you want to see rain that is 200k away, I mean the constant rain, that cannot be perceived from the radar if it's too far. In terms of storm, the radar covers it better because there's better vertical movement, but the coverage is at the most 230k, and the more we step away from the radar, the more information is degraded. So that can be contrasted to visiting the doctor and running some tests. You must follow what they tell you, for instance, instructions to get an x-ray. The storm doesn't follow any pattern. They take any way they want, they go wherever they want. So there are many limitations. So let's then move on to verification or checking. In terms of social network, there are many. I obtained this image on internet, and some of this logo I am not aware of. Instagram, Facebook, Twitter, YouTube, WhatsApp are the most popular. There are new ones all the time. So there are social networks that are in and then they're not in. I heard that Twitter is falling now. So I don't know. Instagram, I can see in Argentina, is used a lot, and that could change, could vary from one country to another, what's in. So, how would we do this data mining in Facebook? Facebook, unfortunately, in Argentina, it doesn't help us much. We can't find how it can help us, actually. Remember, we have information coming in every 10 minutes. It's just one or two people for this region. So to devote time to this could mean a lot of time if the storms keep up appearing. In the case of Facebook, we can, however, look up there. We can write down hail and you'll see the results. The problem with Facebook is that one algorithm will order the info, so it is not ordered by appearance, and filtering is a bit tricky. We need to come to this region, for instance, the labeled location, and we can type Buenos Aires, Palermo, or the area that we are interested in. Also, we can filter data by writing down a date, for instance, the year and up to what month, and that will help us filter the results. But when it comes to getting information, Facebook is not cool. Now, what is good about Facebook is the live map. I wonder if you're familiar with it. If you go into this address, you'll have a georeferential map of the world, and you can use it as the Google map. You can scroll with the zoom. And here I got close to Buenos Aires. There it is. Buenos Aires. So this is Buenos Aires, and that's the province, and then Uruguay on the right. So these dots are the stream videos through Facebook. So any live video will show here. So if you stand on these dots, you can see this video. And if it's outdoors and there's a storm happening, you can check what's going on. And the dots that are on and off are the ones where you can have a lot of viewers. Then Instagram, again, used a lot in Argentina, but not very friendly when it comes to obtaining info from it. The way in which we have managed to work with it is, for instance, write hashtag hail or whatever you're interested in, and then you will see relevant results. Again, an algorithm will say what you're most interested in, but it's not the most recent. So you'll have to go down into the web page and get to the most recent, and then you will have the results. So this is the downside of looking at data in social network. For instance, there is a beer house called Hail in Chile, for instance. So many things appear that have nothing to do with what you want to get, you see? So, one other thing about Instagram that is negative is that we cannot georeference the info. You get the most recent labels related to hail, but you'll have to go into them one by one to see whether that region is of any interest to you. So, about Twitter. Twitter is the tool that allows us to filter info. It is very data mining friendly. I imagine that Instagram and Facebook also can do data mining, but they are paid. I am focusing on free services, but if you talk to Facebook or Instagram and you pay, perhaps you could do more exhaustive data mining. These are options that are free of charge. Twitter is free completely. If you go to this link, you can obtain this menu, and you can find many options. I wrote hailstorm in the negative and the feminine form in Spanish, and also I wrote stones because many people say stones are falling, referring to hailstorms. So Twitter will look for publications that have it's hailing, it hails, there's hailstorms, and then you can also have exact phrases by using colons. And here I'll show you the example. We looked for plural feminine hail forms and stones, and what appears is this. That is not the most recent anyway. And if you stand here in the search button, you'll see the code that Twitter used to find the info. See? So this is the code that you filled out in these lines, and you get all this info. So you could edit this. I could stay there, and if stones is bringing up a lot of results that are not needed, I can just erase it. Also, I could broaden the 15-mile radius, so I could stand in within and change it. So maybe I could erase it and say 30 miles or 200k rather than 20. So the limit is 2500k. Also, you could look up more complex searches. If there's a strong storm and I want to see something else, I could say gusts, wind, storm, heavy rain, any result in Twitter that has this word within the region that I have will appear. So if there's not a city, it allows for a geocode, latitude, longitude, and the radius that we define. So I've observed that at some forecast offices, they define some circles to cover the area of interest, so they know that this is the north of this region, the north of that region, and that's how they can compile different sections. So Twitter makes available all the rules to edit this geocode, and you can see them on the screen. TweetDeck is the most comfortable tool for operative work. To come to the page and look up one thing at a time is not the most comfortable. One can do it if you don't want to do it in real time, but TweetDeck is the tool to work in real time and in an operative office, just ours. What's TweetDeck? It's a Twitter tool that is available, and it has different columns in which you do the searches, and also they appear in every column. So you can write hail, flood, flooding, waterlogging, downpour, rain. You can set up a column and it can show you the results. How do you go about it? Here on the left, there's another button that opens up this screen. So you can choose what you want to look up and for it to appear on these columns. For instance, search, as I did here. So you click here and you'll have one column in which you can have the word or the word combination that you want. And as you can see, you can use a lot of possibilities. I'll show you an example with hail also that shows up a lot, and we had to remove it. So here you click and you have all these combinations will appear. I will show you some uses that we are giving to TweetDeck. If you click on these columns, you will have the menu on the right. So you will see the combinations chosen. For instance, flooded, flooding, waterlogging, waterlog, whatever. And then what's interesting here is that you can write all tweets, be it with or without images, or you can say only tweets with images or only tweets with videos. If you want to see hail and you want to look at the size of the hailstone, you look at images perhaps. And you click over here. So in every bar you click, you get this menu. If you click here, you get this, and if you click there, like that. Well, it's quite intuitive, quite user-friendly, so you can go around it. As I was saying before, I gave it the words. However, I excluded, for instance, red hail, because there's a very popular song called Red Hail. So many times we get a lot of links related to this song. So we say exclude the song Red Hail. Because we believe that it's quite unlikely to have anything related to red hail referring to the weather, right? So if you, let's go back a bit. If you click location over here, you will see a Google map where you can go in and move. This is a little map where you can move through clicking, and you find the tweets around this circle here, in which we define the radius that could be up to 200k on the TweetDeck, and in the geocode, as I said, you can even reach 2500k. So the negative part about georeferencing results is that you will only have the tweets in the users that have allowed for the cell phone to use GPS, right? Some people don't. So that will mean that you'll have fewer results. And the benefit is that it is quickly georeferenced. So we restrict our search to a region that we are interested in. So only people, well, that's just what I said. So something else that is found on TweetDeck, whether you want to follow some specific users. For instance, as I will be telling you, you can follow star meteorologists, for instance, that might post information in Twitter that reaches them through other information sources. Some meteorologists that are well known on TV that get information via WhatsApp. So they get that picture and have it be on Twitter. So if you follow this group of media meteorologists, you can find out through them. Also, this might happen with mentioning. Many people wish to mention to them that there's hail. So you can set a list with people naming it. For instance, that's also another way in which you can get to know the data you're looking for. You could create a list, and on this list, you will be adding users, for instance, famous meteorologists or civil defense or protection. This is the Twitter page of Civil Defense of the province of Buenos Aires, and if you do add here, add to the list, you can add it to the list, for instance, such as I created here, civil protection, right? So that will all be part of the same column on Twitter. So you have the posts by all civil defense that you've added to this list. So here's the example: civil protection and other, journalists and amateurs. Amateurs are also a source of information, and I didn't add it here. I don't know about other countries, but in Argentina there's a Met forum for amateurs, and many people are constantly digging up the social media and post here. So if you check the info on that forum, you might come up through some info because a lot of people are doing the job for you. So that can also be handy. As I said, the key is how large the area to watch is and what the workload is. We talk about optimizing work. You could look up a lot of reports, but you forgot to look at the radar image. And you know, storms evolve really quickly. Supercells here can go from nothing to, in half an hour, to have a very, very big storm. Another example that I wanted to mention is that many times in mass media, there is a hashtag that becomes fashionable. For instance, a news channel wrote "It rains in" as the hashtag. So people just say "It rains in Mar del Plata," "It rains in Buenos Aires," and in a tweet deck, you can add the hashtag "It rains in." And you can combine hashtags because every channel has their own. So that's one other column that you can add at the tweet deck. So, Waze reports. This is an app to see how to get to places, but in Waze you can get relevant information regarding the weather as well. If you go into waze.com, you can see on the screen, you can see this map. You have to zoom in, and then you'll see the icons. First of the cars that are driving and reporting. You cannot interact with them, but they show you the movement. If you zoom further in, you will see the reports. For instance, the people in their cars. I never understood how this works because you're not supposed to use your cell phone while you're driving, right? But still, things come up in ways. I wonder if this is legal. Anyways, most relevant information, two things. This symbol that is blocked, it's like a red cross, and that tells you that the road is blocked. So it says because of construction, for instance. People usually say why the road is blocked. If there's a strong storm and a tree fell down or there's waterlogging, people will say what happened, right? So when there is a storm, you can go into Waze and check whether there are these symbols or not and why the road is blocked. The other symbol is this sign, this warning sign. It's an exclamation mark. And here also is that a car has stopped in the middle of the road. So usually, if there's a bad weather, they indicate the reason why things have been affected. And one good thing about Waze is that they tell us when the posting occurred. So that's also significant, right? So not when the event occurred, but when it was reported. Right. So the problem with using network information is that it depends on people being there that are awake, that wish to publish that info on the social network. And so depending on how many people live there and how broad the region is that we are observing, we can have a lot of reports, such as a place of a city that has a lot of population, and then isolated reports for people who live in the rural areas. And this is where things come in. Do I believe this report or not? You want to get feedback, but you want your information to be reliable. So one report could be doubtful. Several reports, you can say, well, if there are a lot of reports, it would be really weird that everyone is sending fake info at the same time, right? So several reports increase your trust. If you have several reports and in the radar image you see something that's pretty intense, then the level of trust increases even more. If also you have lots of pictures, you increase your trust in this source. And as I was saying, this has a lot to do with the time at night, fewer, during the day, more, and also how many people. Also, another effect to take into account is that if there is a big storm affecting communications, then the amount of reports will go down because people will not have internet, basically. So, if you have images of tornadoes, for instance, or hail that are significant, you're always interested to know whether that image is true. And so what you could do is go to images.google.com or tineye.com and look for similar images on internet. If there's a tornado, for instance, you can double check through Google, who will be looking for similar images on the web. And this includes the date of publication. So that's really helpful. Again, this has to do with the workload, but in the case of a tornado, it's a significant event, so you can quickly verify whether this image is truthful or not. When it's truthful, there's more than one video or image from different angles of the same tornado, and that increases your trust in the fact presented to you. So now we will go to something else. Twitter is useful for finding information in Twitter, but we were trying Trendsmark that is not free, so we tried it for a bit. And what's good about TrendMap or similar, that it's georeferenced through a map, similar to Google Maps, and you see the live posts and the most recent ones. You can animate the past 2 hours and you see all these dots in the tweets that you define. So you can look up hail, hailing, and it'll be in blue, tornado, red, different combinations, different colors that will appear in this animated map. the size can be configured as being fixed size. So the good thing, the added value, is that it is georeferenced in a map with all the search laws, and the bad thing is that you have to pay for it. Another social network that we've been taking into account but does not operate in Argentina but we thought was worth mentioning is called Nextdoor, a social network that operates in Europe and the US, and basically it's like Facebook but geographically defined, so it puts people in touch who live in the same neighborhood. And interestingly enough, you need to verify your identity there. I cannot log in using any name. To be an extra user, you need to show who you are. And through identity verification, many national organizations, for instance in the US, are also taking part. Nextport is part of the Weather Ready Nations programs that we might refer to later on. So what's good about this is that there's communication between a verified user, that you know where they live, and the government can also send the information. And it is mostly focused on this, preparing the community, apart from being a neighborhood sort of Facebook. So we thought this was very interesting if it ever comes to Argentina, as something to watch for. Another challenge is to generate an app so that people report to us. So what's good about Twitter or Facebook is that people do it out of their own initiative. There's hailstorm, it damaged their car, they share it. Their house got flooded, they share it. They feel the need to share. So in an app, it's harder because people might not do it on an everyday basis. In the weather service, we generated in a program called alert.r, an app that is available on Google Play, in which people can report different phenomena in Argentina. So if it's hail, they give examples so that they can measure, be it the hailstorm of the size of a pea, of a ping pong ball, of an orange, so that they don't need to measure the hailstone. Information is shown in a map, and for instance, rain was reported in the province of Buenos Aires in this case, and some people continue to use this app. The thing is how to make it go viral. How do we get people to use it in the same way they use Twitter or Facebook? So some improvements in terms of the browsing options, how to make things popular or viral is one of the key questions, right, being asked in social networks. And one other thing that media is thinking about is how the community can open up channels that are two-way. So what we want is to distribute alerts and short-term warnings in a more effective way. So, for instance, there's a survey here, and it's got age groups. So, how do they prefer to receive meteorological alerts? The youngest prefer the app, and the other WhatsApp. So, between 30 to 40, more on WhatsApp and the app. And well, you see the difference. So, cell apps and WhatsApp seem to be the preferred choice. If you add up all the answers, I believe 45% wanted to get it through the Cell app, and 30% via WhatsApp, and Twitter 8% and Facebook 8%. So that's interesting. So how can we promote having information be sent to the service? We're working on making a hashtag become popular, for instance, reports, SMN. This is just an idea in which anyone can report to us from any social network, be it Twitter or Instagram. And that's all from me.